video will review the Georgia Standards of Excellence 3 MD7, which focuses on relating area to multiplication and division. Part A of 3 MD7 states that students will find the area of a rectangle with whole number side lengths by tiling it, and show that the area is the same as would be found by multiplying the side lengths. Part B states that students will multiply side lengths to find areas of rectangles with whole number side lengths in the context of solving real-world and mathematical problems, and represent whole number products as rectangular areas in mathematical reasoning. Part C states that students will use tiling to show in a concrete case that area of a rectangle with whole number side lengths A and B plus C is the sum of A times B and A times C. Use area models to represent the distributive property in mathematical reasoning. The Achieve the Core Coherence Map shows that 3 MD7 is connected to several standards in 1st, 2nd, and 3rd grades. Let's take a look at the standards that lead up to 3 MD7. In 1st grade, students compose 2 and 3D shapes from other shapes to make a composite shape. While in 2nd grade, students begin to partition rectangles into equal rows and columns with same-size squares, while also using a variety of measurement tools to measure the length of different objects. Before diving into 3 MD7, 3rd grade students will first understand unit squares and tiling of a figure without gaps and overlaps, and they will also find the area by counting unit squares. It is also important to point out that 3 MD7 is connected to 3 OA5, which deals with the properties of multiplication, and 3 OA8, which deals with two-step word problems. 3 MD7 then directly leads to 4th grade standards on area and perimeter, and sets the foundation for understanding volume in 5th grade. As you research 3 MD7, it is important to point out that Part D of the standard was moved to 4th grade. The Georgia Standards of Excellence no longer require 3rd grade students to find the area of composite shapes. This standard is now 4 MD8. As students dive into understanding area, it is important to use a variety of concrete manipulatives and models so students can build rectangular arrays while counting square units, with same-size squares without gaps and overlaps. In the upcoming task, students use square tiles to design a sticker sheet that has specific measurements. The order specifications require that all sticker sheets must be rectangular, with only whole units that are arranged in rows and columns without any spaces or overlaps. After using predetermined side lengths to find the total number of stickers, or square units, students then find the length and width with a set number of stickers. Students soon discovered that their lengths and widths could vary even if the total number of square units are the same. So you guys are going to work for the sticker company, and in front of you, you have 24 square units or stickers. And what you need to do is design a page that these 24 square units can fit on, so that a sheet of stickers can be made with those 24 square units. So see how you can arrange your square units onto one page, or into one rectangle. What's the length and width of your sticker page?
3 times 8 equals 24.
How did you design your sticker page?
I have a length of 6 and a width of 4.
So what's the length and width of your sticker page?
2 times 12.
As students build rectangular arrays with concrete models and move to grid paper, which is more representational, they discover that area can be found by multiplying the side lengths instead of counting individual squares. They also discover that the size of the square unit affects the overall size of the rectangle. Although there are 20 square centimeters in the yellow diagram, 6 square inches is larger. Racing rectangles is a great task to implement as students explore area. In the task, 2 students roll a set of dice as they race to build arrays while striving to cover the largest area. After a predetermined number of rows, students can then calculate the area of each rectangle and find the total area. Equation goes with your model.
3 times 4.
And how much does that equal?
12.
1 times 4. Equation goes with your model.
1 times 4.
1 times 4. Okay. And how much does 1 times 4 equal?
4.
In this online game, students strive to build rectangular arrays with the given products. The goal is to completely cover the grid without any gaps or overlaps. As students solve the puzzle, they often have to adjust their factors while still maintaining the same area. In addition to playing the online version of the game, students can create their own game boards for their classmates to solve. The template to this puzzle can be found below the video. To create the game board, students simply move the blue tiles and position them so that they completely cover the entire grid. The students then move the appropriate product or area into each rectangle. Before sharing with their friends, the students can then delete the blue rectangles so that their classmates can solve the puzzle. These puzzles encourage rich conversations and critical thinking while students use a variety of strategies to fill in the grid. After building complete rectangles, thinking becomes more efficient as students transition to understanding how to find the area of a figure with incomplete arrays that only show the length and width of a rectangle. This leads to more abstract understanding as students find the area of a rectangle without models. As the coherence map showed, 3OA5, which focuses on the properties of multiplication, is directly tied to success with 3MD7 as students use area models to represent the distributive property. In the illustration, 8 is decomposed into smaller factors 2 and 6. The partial products are then added together to find the total number of square units. In this clip, the teacher is using a GeoBoard app to model the distributive property. After decomposing the 8 into 5 and 3, the class found the area of each section to discover the total number of square units. After finding the total number of square units, students explored area on their own.
So I multiplied 4 times 1 equals 4, and 4 times 10 equals 40, and I added these together to get 44.
In this video, the student is finding the area of a shape that has a length of 9 and a width of 8. He decomposed the 9 into smaller factors, 5 and 4, to make multiplying easier. You know 8 times 4?
No, but I know my 8 times 2 equals 16.
So how do you find 8 times 4 if you know 8 times 2?
You double.
Double, okay. And what is 16 plus 16?
32.
So now that you have your partial products of 40 and 32, how do you find 8 times 9?
8 times 9.
Okay, 40 plus 32 equals 72.